Good morning, children. Today I am giving you a quote. An ounce of prevention is worth a pound of cure. I repeat, an ounce of prevention is worth a pound of cure. So, children, I think you must have learned chapter 28 and solved the question answers. I have given you assignment also. Please complete that. Today we will learn chapter 29, that is mass energy equivalence and nuclear binding energy. So to learn mass energy equivalence, first we should know what is mass and then what is energy. Mass is the property of matter and energy is the capacity of doing work. You have learned already in the previous classes. Now according to Einstein's mass energy relation, that is delta E is equal to delta mc square. Delta E, that is change in the mass, is equal to change in the energy is equal to change in the mass into square of speed of light. Using this Einstein's mass energy relation, we have in the previous chapters learned one U value is equal to 931.5 mega electron volt. Children, in this chapter we are going to learn the next topic, that is pair production and pair annihilation. These two terms we have done in 11th class, but we will revise it again. Pair production means from energy we get mass. You can see from gamma, that means energy radiation, we get electron as well as positron. So electron and positrons are the particles. From energy we are getting mass. If the energy is greater than 1.02 mega electron volt, then only we will get the pair production. If the energy is less than 1.02 mega electron volt, then instead of pair production, we will get photoelectric effect. So this photoelectric effect we will learn in another chapter. Next topic is pair annihilation, just opposite to pair production, in which these two particles, that means masses, converting into energy. Here the particles are electron and positron. Together will give energy. So from mass we are getting energy, opposite to pair production. The next topic, children, is mass defect, denoted by delta M, mass defect. This is the difference of sum of mass of protons and neutrons with the mass of nucleus. You can see Z is the number of protons and MP is the mass of proton. So total mass of proton is this much. And this is the total mass of neutrons, denoted by here small n. And capital N is the mass of the nucleus. So from the sum of proton mass and neutron mass, if we remove the nucleus mass, we will get the mass defect. Next one is binding energy of the nucleus. Children, this is important term. Binding energy is the minimum energy required to separate its nucleons and place them stationary at infinite distance apart. For this, how much minimum energy is required, which is called binding energy. I repeat again. Binding energy is the minimum energy required to separate its nucleons and place them stationary at infinite distance apart, which is called the binding energy. So how to derive the equation for binding energy? Binding energy is equal to delta mc square. We are putting delta M from the previous equation. This equation we have put for delta M and then multiplied by C square. In the next case, this mass of the nucleus is replaced as mass of atom minus mass of electron. So ZME means the total mass of electrons. So from the total mass of atom, if we remove the mass of electrons, we will get the mass of the nucleus. So we are replacing mass of the nucleus by these two terms. Next step is, here is minus, here is minus. So this term become plus, and this term we are adding with Z mass of proton, we get Z mass of hydrogen, because hydrogen contains one proton and one electron. Thus we get the binding energy equation as Z mass of hydrogen plus A minus Z mass of neutron minus mass of the element multiplied by C square. So this is the formula for binding energy, and the derivation is important. Next topic is average binding energy. Average binding energy is the total binding energy divided by number of nucleons. So this average binding energy gives us the stability of the nucleus. If the average binding energy is high, then the stability of the nucleus also is high. You can see a graph of average binding energy in mega electron volt versus mass number A, in which you can see the highest average binding energy is that of iron, Fe56, and before 56 and after 56 you can see the average binding energy is less. So more the average binding energy, more is the stability. This is all about the chapter 29. Children, please do the homework pages 1026 and 1027. 1026 and 1027. Thank you.